Jai Hind to all. Myself, Dr. Y. N. Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to teach that very important topic, that is boot algorithm in section of the computer organization and architecture. This topic is very important regarding to the university examination and GATE examination also. Every year asks this question in university examination and 1 and 2 marks question in GATE examination. Now, first we discuss what is the Booth algorithm and why it is differ from the another multiplication algorithm. When we apply the array multiplier, then array multiplier used for the normal data multiplication, not used in sign multiplication. But in Booth multiplication, that is the sign multiplication algorithm. It means if number are negative, then both multiplication used of the two numbers. The negative number are compute using the 2's complement. Now, these are the very simple hardware architecture of the Booth algorithm. In Booth algorithm, especially first one is a sequence counter. Sequence counter is count the number of the bit available into the multiplicand or multiplier. And BR register and AC register. These two register that is the use for the multiplicand, multiplier, and these are the accumulator register in which we perform the multiplication operation. Here is a multiplicand, here is a multiplier, and we find the complement and use the parallel adder of the BR value, that is multiplicand. And in QR, we perform the multiplication, and in Qn plus 1, the starting is a 0. And what is the Qn? Qn is a first bit of QR. These are the very simple architecture, hardware architecture of the Booth algorithm. Now, this is the flow chart and algorithm. We are also going to discuss of this flow chart. Multiplicand in M and multiplier in QR. In hardware, that is the BR, but in here we multiplicand in M, and QR is multiplier. Accumulator register in starting 0, sequence counter, that is the number of bit present in multiplicand or in multiplier. And in starting Qn plus 1 is 0. Now the second step, we check Qn plus 1 and Qn. If it is 0, then we test only the first bit. 0 stand for the positive and 1 stand for the negative. It means 0, 1, we add AC and multiplicand. In AC, if it is 1, 0, then we perform the AC minus BR or AC minus M. After that, we shift, arithmetic shift AC and QR, and SC is equal to SC minus 1, not plus, SC is equal to SC minus 1. After that, we check SC. If SC is 0, is equal to 0, then end the process, and the result are in AC plus QR. When SC is equal to 0, then result are in AC plus QR. AC and QR not plus, and when it is not 0, then move into this one and we again check Qn and Qn plus 1. Now, we write the very simple algorithm for this flow chart, where I write this algorithm. Now, here write the first algorithm, then we take the very simple example to understand the both algorithm. Now, in the step 1, the whole algorithm are classified into the 3 steps. Step 1, that is multiplier in QR and multiplicand in BR or M. And in starting, AC is 0, SC is N, and Qn plus 1 is 0. Now, this is the first steps. Now, step 2, check Qn and Qn plus 1. If it is 0, 1, then AC plus M and SC is equal to SC minus 1 and arithmetic shift AC and QR. Now, if Qn and Qn plus 1, that is 1, 0, that is 0, we perform the plus operation. If it is 1, 0, then AC minus M, and these two process repeat on this state. Now, arithmetic shift AC and QR and SC is equal to SC minus 1. Now, the third one, if Qn and Qn plus 1, that is 0, 0 or 1, 1, then no operation is performed and only arithmetic shift AC and QR and SC is equal to SC minus 1. Now, this is the 2 steps of the Booth algorithm. Now, the step 3, check SC. If SC is equal to 0 and if SC is equal to not 0, then go to step 2. This is the very simple algorithm of the Booth algorithm. Both algorithms are classified into the 3 steps. Actually, this algorithm is derived from this flow chart. Now, this one is known as the step 1. This one, whole process is known as the step 2, or this one known as the step 3. This one known as the step 1. From this one to this one, that is known as the step 2. Now, this one is known as the step 3. Okay, now we take the very simple example to understand the both algorithms -5 and -7. The first one is M and the second one is the BR or QR and M and QR. Now, in starting, AC should be 0, that is 4 times 0. Now, what is the QR? Now, QR is -7 and what is the BR or QR -7? 7 means that is 1 0 sorry 7 means 1 1 1, that is the 7, and -7 we find the 2's complement and sign bit is on. Now, what is the complement? This, that is 0 0 1, and what is the -7? -7 is, that is 1 0 0 1. Now, this is the 1 0 0 1, that is the -7. And what is the SC? SC is 4 times 4, that is 1 0 0. Now, what is the -5? What is the 5? 1 0 1, and find the 2's complement. 2's complement means that is the 1 complement plus 1, that is 0 1 0. Now, plus 1, that is 1 1 0. Now, this one is known as the MR, that is known as the BR. Now, we find again BR plus 1. Now, that is 0 1 0 0. Yes, that is 1 0 1 0, that is the BR plus 1. Now, that is the BR. We write down here is a BR 1 0 1 1, and what is the BR plus 1, that is 0 1 0 1. Now, in starting, that is QN plus 1 0. Now, this step 1, check QN. What is the QN? QN is the first bit of the QR, and QN 1 plus 1 in starting 0. Now, check QN and QN plus 1. Now, QN and QN plus 1, that is 1 0. For the 1 0, just we see the algorithm 1 0, we perform the subtraction operation. It means AC minus BR. Now, what is the AC? It means we add this one 0 1 0 1. Now, 0 1 0 1. And what is the next operation? We see the algorithm arithmetic shift and SC is equal to SC minus 1. Arithmetic shift means shift first bit added is 0. Now, here is 0 1 0. This one shift from here, that is 1 1 0 0. Oh, now this shift is 1 here, and SC is equal to SC minus 1, it means 0 1 1. And check SC. SC is not 0. Again check QN and QN plus 1. Now, this is the QN. Now, this is the QN plus 1. Now, QN and QN plus 1, that is 0 1. And for the 0 1, what is the procedure? SC is equal to AC plus BR. AC is equal to AC plus BR, and arithmetic shift, and SC is equal to SC minus 1. Now, this is the AC. What is the BR? Now, this is your BR. Now, 1 0 1 1. Now, 1 1 1 0 1 and 1. For this condition 0 1, we add an arithmetic shift. Now, arithmetic shift 1 1 1 0. this one is shift from 1, 1, 1 and 0, and here is a 0, and SC is equal to SC minus 1, that is 0, 1, 0, and check SC. SC is not equal to 0, again we process the same. Now again check, this is the Qn plus 1, that is the Q1. Now Q1 and Qn plus 1, that is 0, 0. For the 0, 0, we perform the only shift operation. Now shift operation, that is 1, 1, 1, 1, 0, 1, 1, 1. Now here is a 0. Now here is a 0, 0, 1. Check SC. SC is not 0. Then again we check Qn, and now Qn and this one. What is the Qn and Qn plus 1? That is 1, 0. And for the 1, 0, AC plus BR 2's complement. Now here is a 0, 1, 0, 1. This for the 1, 0 or this for the 0, 1. Now here is a 1, 0, then we add this one, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, and carry bit or discard, and then shift AC and QR. Now here is a 0, 0, 1, 0. Here is a 0, 0, 1, 1. Here is a 1. And SC is equal to SC minus 1, that is 0, 0, 0. Now if SC are 0, then end the process, and the result are stored in AC and QR. Now this is your final result. The final result is 0, 0, 1, 0 and 0, 0, 1, 1. This is our final result, that is minus 7 multiplied by minus this. Now this one is a 35 answer, and you can check the answer. Now this is a very simple example of the both multiplication algorithm, and we take another example for the better understanding of the both algorithm. We take the another example, that is minus 4 multiply minus 5. Okay. Now that is very simple. First we convert these number using 2's complement in binary form, and one is in QR, one in is BR, and we follow the algorithm. Now in starting, AC is 0, 0. Now first we check what is the bit value, what is the 4, that is 0, 0. What is the complement of the 4, that is 0, 1, 1, and plus 1, that is 1, 1, 0, 1, 1, 0 and 1. Now this is the 4. Now in QR, that is 1, 1, 0, 0. In Qn plus 1 in starting 0, and what is the value of SC? And SC is just 4, 1, 0, 0. Now what is the minus 5? That is BR. Five, 1, 0, 1, that is 5. What is the minus 5? That is 0, 1, 0 plus 1, that is 0, 1, 1, and now this is the minus 5. That is the BR. And what is the BR plus 1? that is 0, 1, 0, 0 and plus 1, 1, 0, 1, 0. Now we need the two value, this one and this one. So just we write here what is the BR? BR here is a 1, 0, 1, 1 and what is the BR plus 1? 0, 1, 0, 1 and we perform the operation. That is very simple. We check the Qn and Qn plus 1. In starting Qn and Qn plus 0, 0. Now Qn and Qn plus 1 that is 0, 0. In 0, 0 we simply perform the, for this 0, 0 we simply perform the arithmetic shift and SC is equal to SC minus 1. Now this simply shift 0, 0, 0, 0, here is a 0, 1, 1, 0 and here is a 0 and SC is equal to SC minus 1 that is 3. We check SC, SC is not 0, again we check the Qn and Qn plus 1. Again Qn and Qn plus 1 0, 0, then again we shift, arithmetic shift and SC is equal to SC minus 1. Now again 1, 0, 0, 0 and here is 0, 0, 1, 1 and here is a 0. Now here is a 3 minus that is 2. Again we check SC, SC is not equal to 0, then again we check the Qn and Qn plus 1. Now in this time what is the Qn? Qn and Qn plus 1 that is the 1, 0. 1 and 0. What is the n0? We add BR plus 1 and arithmetic shift and SC is equal to SC minus 1. Now 0, 1, 0, 1. Now 0, 1, 0, 1 and arithmetic shift that is 0, 0, 1, 0. Now 1 is here, 1, 0, 0, 1 and here is 1. Now here is a 0, 0, 1. Again check SC. If SC is not 0, then we again check Qn and Qn plus 1. Now in this time Qn and Qn plus 1 that is 1, 1 and for the 1, 1, for the 0, 0 or for the 1, 1 we simply perform the arithmetic shift and SC is equal to SC minus 1. Now simply arithmetic shift that is 0, 0, 0, 1 and here is a 0, 1, 0, 0 and here is a 1. Now here is a 0, 0, 0. If SC is equal to 0, then end the process and the result are in our AC and QR. Now this is your final result, that is 20. You can check it. Now this is the Booth algorithm. In next lecture I will meet you some important topic of the computer organization and architectures. Thank you.